Hello and welcome. This is now question 4 for Edexcel's S1 June 2011 paper. Okay, so this question is all about normal distribution, and essentially the case that we're given is time taken for a couple of people to run a 100-metre race. Now that's completely irrelevant, we don't really need to bother with that, okay? But we're told that the mean time is 16.12 seconds and the standard deviation is 1.6. I put 1.60 but just to keep it to the same decimal places, but I was just being pedantic. Seconds, okay? Now, what we have to find in part A is that the probability that x is less than 15 seconds. So obviously the first thing we do, and the first thing we always do in these questions, is draw a normal distribution. Okay, which looks something like this. I do apologise for my crud drawing. And you have to remember, obviously the mean is in the middle, 16.12 seconds, and you add, so a range of 3 standard deviations on either side of the mean. Okay, so if you add 3 standard deviations, 3 times 1.6, if you add that on, you will get 20.92. And if you take the 3 standard deviations away, you'll end up with 11.32. Remember, these are all seconds taken to run the 100-metre race. Okay, so it has to find the probability that x is less than 15. Well, obviously what we do is we draw on the line where x is 15, and it's obviously on the left-hand side of the mean, 15. Now what I would do is continue to draw that up and shade in. We want x is less than, so it's on the left. Okay. So, what we do now, well, we've got our x value, we've got our mean, we've got our standard deviation. The only thing we don't have to work out the probability is the z value. Okay, so we standardise the values. We use z equals x, take the mean, over standard deviations. Okay, and just a quick overview on where that comes from. As I said, only take a second, okay? So basically, obviously we've got 3 standard deviations on either side of the mean, okay? But you do x take u to whether it's on the right hand side of the mean or whether it's on the left hand side of the mean. Obviously that will give you a positive or a negative z value. And we want to work out what fraction of 3 of the amount of how many standard deviations on either side. So that's why we divide it by the standard sigma, standard deviation. Okay, so that's just a brief overview of a way of remembering that formula. Okay, or you can just simply remember it. And then we sub in our numbers. Okay, so x to be 15, mu to be 16.12 over the standard deviations are 1.6. Okay, so therefore you get a z value equal to negative 0.7. Okay, so that is our z value. Now, obviously, what we do here is you could draw another standard deviation. Okay, so normal distribution even. It's like something like this. Right, and it's negative 0.7, so it's on the left hand side of the mean. You draw 0, positive 3, negative 3, and we want x to be less than 0.7. But because we don't have a negative 0.7, and we don't have a probability that is obviously, it's going to be less than 0.5, but what we do is we can draw it on the other side of the, so basically the probability that z is less than negative 0.7 is the same as saying, well, the probability of z is greater than positive 0.7. Okay, so you use that idea, and really I'm just going to draw the graph again. So I do apologise for my crud drawing. So yours will be better than mine. So you just draw it on the right hand side and we say that is equal. And then you look to the value where the probability that z is less than positive 0.7, you take 1 away from that. So in other words, you take 1 away from that is equal to 1, take 0.7580, which obviously gets you 0.2402, that's why I had to check that out. Okay, so that's your answer for part A. The probability that x is less than 15 seconds is 0.2420, or in other words, 24.2%. But you've never converted to percentages, you would always leave it as that. Okay, so don't be put off by that's a really small number, even though you should just be familiar, hopefully, okay with that. Right, so part B, that's part B asks us to do. And part B says the medals are given to the fastest 30%. In other words, the lowest 30%, okay? Because obviously we're talking about the time to win a race, and obviously slower is better, unfortunately. If faster was better, then I'd be top. Anyway, so it wants the... Obviously we're looking at the same situation, so we draw the same normal distribution, okay? Like that. We want the fastest 30%, okay? And the fastest 30% are obviously faster than the fastest 50%, okay? So it's on the left-hand side of the mean. We don't know what this x value is, but we know that the probability that the value is less than this... we want the slowest time to receive a medal, okay? So basically we want this x value here, okay? Basically, everything on the left-hand side of this x value is the probability that the value will be less than x is 0.3, and the probability therefore that the value of x will be greater than this will be 0.7. Okay. Now what you would draw on here is the same values that you drew on for the graph above. So 11.32 as the lowest value, okay, and 16.12 is the mean, and 20.92 as the maximum. Okay. So what we would do then is obviously we need to draw this again, but instead of drawing it with the actual values on, we need to draw it like we've done here, standardise it. But obviously we can't get a z value if we don't have the x value. But because we've got the probability, you could just look in the table, the value that, the probability that x is less than x is 0.3, okay, and the probability that x is greater than x is 0.7. Okay, or in other words, what you could do is look for the probability, because we want the z value here, that the x is less. The probability that x is less than x is 0.7, okay, which is obviously getting me the x value on the other side of the mean, the same distance away but on the other side, and we need to take the negative version of that, okay, and the probability that x is less than x equal to 0.7, okay, if you look that up, that's 0.52, but because our value is going to be on the other side of the mean, but the same distance away from it, if you can think of it like that, is negative. Okay, so it's negative 0.52, and that's our z value. Okay, so negative 0.52. As I said, I'll just draw it on. And going on the right hand side of 0.52, same as the left hand side of this x. Okay. So what we do is put it into the formula now. Now we now have the value for z, well it's 0.52, okay, and that's equal to x, we don't know x. Take the mean of 16.12 over 1.6, times both sides by 1.6, and then add 16.12 to get 15.29 seconds to 2 decimal places. Okay, so that is your answer for question 4. I tried to explain this part B. I don't think I've done a particularly good job. So, as I said in the previous videos I've done, if you want me to have another crack at that part B, please do let me know. But it's just a case of drawing it again and again and again. I could have easily ended up drawing 4 or 5 normal distributions there, but I just tried to explain my way around it because I'm lazy and I can. Okay, but really, what you would do if you were going to draw normal distribution graphs. Again, you would obviously draw this one to start off with, and then you would draw the x on the other side, okay, and have that value of x, the probability that it was greater than this value, the opposite value of x, okay, to be 0.3. So obviously the value on the left hand side would be 0.7, and that's essentially what we've done here when we've turned it into a z value. We've looked at the probability, okay, that the number is less than x, z is less than z to be 0.7, so therefore the probability that it must be greater must be 0.3, okay, so that's 0.52, and then we just put, obviously we've got positive 0.52, well that would be this if x was over on the right hand side of the mean, but we've got it on the left hand side, so we take the negative version of it, which gets us obviously negative 0.52, put it into the z formula, which we've got over here, and then rearrange it to get x, okay, so we timed both sides by 1.6 and added 16.12, which got us 15.92 seconds, which is what we would expect. If you obviously got a value that was greater than 16.2, or as I said, a lot nearer the 11.32, then you would know you were kind of wrong. Okay, so hopefully, as I said, that explained a few things. So thanks for watching, and as ever, we'll see you in the next video if you decide to stick around. The next video is all about frequencies and midpoints and stuff. So it's quite an interesting question 5, and there's a few things that I want to point out, obviously, as I always do. Okay, so thanks for watching, and hopefully I'll see you in the next video.